In the CCNA security class, part of the curriculum focuses on attacks and security that needs to be implemented from inside the network. So if we look at this network right here that we've got the exterior, the outside, right? We have a perimeter router here, and then here's the cloud, the internet. So this is exterior. So there are attacks that come from outside of your network coming into the network. But we also have to worry about attacks, network attacks from inside the network, from the interior of the network, right? So in this case, we've got perimeter router, and then we have a firewall router, and then we have 3 switches on the inside of the network, and then we have hosts attached to these switches, and we have separate VLANs. So we have to worry about attacks not only from the outside, but from the inside. Now, how does this happen? Well, maybe this company has a disgruntled employee, or maybe by accident a worker ends up bringing in their own computer from home and putting it on the network, and it has a virus and it attacks the network. Or maybe they establish remote communications from inside the network, which opens up a hole into the network created from the inside out, so to speak. Maybe the attacker is inside the network and tries to introduce a network device. Maybe tries to add a switch to the network, or a wireless access point to the network, or something like that. So a lot of attacks that that are the hardest to defend against actually come from inside of the network. So in this tutorial, I'm going to talk about layer 2 local area network LAN security practices that you can implement inside your network. And we're going to focus on security measures that you can put on a layer 2 device, meaning a switch. So we'll put some configurations on this switch right here, which will help improve security and help to mitigate certain types of attacks that could happen inside the network. So I've got this other document here I want to show you. So we've got this document that talks a little bit about this. So when we're talking about switches, right, and the types of attacks, we've got, first of all, on the top here, access attacks to the switch. So what we're talking about is switch access control security, right? And what does that mean? Well, it means authentication, which is the user accounts and passwords, right? Instead of having one user, one admin user for the entire switch or the entire router, right, it's best to have individualized user accounts and passwords. Authorization levels, what are their privileges, right? Who's got privilege level 15 for enable privileges to get to the configuration modes on the switch, right? Is there logging enabled? So this is AAA security right here. Physical security, how is the switch, how is access to the switch physically controlled? Is it in a locked room? Can anyone have access to the console port? Remote access security, have you correctly configured your VTY ports, your auxiliary port? Are you using Telnet or SSH? You know, SSH is secure, Telnet's not. What kind of encryption are you putting on your passwords? You know, MD5, Type 7, what type of encryption are you using? And then are you employing a policy of password strength on your passwords, right? So on this level, we're talking about access attacks, management control over the switch, right? You want to make sure that nobody can gain management control over your switch. Now, in this tutorial, I'm going to spend more time talking about this second area down here, which is LAN attacks, local area network attacks at layer 2. And we're talking about attacks that attack the VLANs and layer 2 protocols, right? So we're talking Cisco Discovery Protocol, DTP, STP, Spanning Tree Protocol, and VLANs, right? And let's go down the list here. So VLAN hopping, an attacker could try to get access to a switch and then jump from the VLAN that the switch has been configured for to other VLANs, and then if you can jump from VLAN to VLAN, you can basically attack other networks, right? Other broadcast domains or other VLANs on site of the interior network. So you want to make sure that you don't let attackers hop from VLAN to VLAN, right, and enable them to basically jump from network to network. So to help defend against VLAN hopping, we're going to need to disable DTP, Dynamic Trunking Protocol. DTP allows ports to auto-negotiate from an auto mode into a trunk. And if attacker knows that DTP is enabled, then they can connect to that port and basically send trunking protocol information on that port, and the port on the other side will automatically switch to a trunk, and now they have a trunk and access to all VLANs quite possibly. So VLAN hopping is one way to mitigate that is to make sure that DTP is not enabled. But on a lot of Cisco switches, it's enabled by default, so we're going to need to disable that. Another thing we're going to need to do is to basically not use the default VLAN. By default, all Cisco switches start up in kind of an auto mode with as members of VLAN 1. And as members of VLAN 1, also the management VLAN is in VLAN 1 and the native VLAN is in VLAN 1, and so a switch that has not been secured or properly configured, anyone basically connecting into that switch can try to access the management area of the switch by going across VLAN 1, because that happens to also be the management VLAN. So we're going to need to move VLAN 1. We can't disable VLAN 1, but what we can do is we can configure the switch ports to not be members of VLAN 1. Okay, and then the next thing is native VLAN 1. Now, native VLAN 1 is used for backwards compatibility, and another VLAN hopping technique that is possible is double tagging VLAN hopping. And what that is when a packet goes across a native VLAN trunk, the VLAN ID is stripped from the packet, so there's no VLAN ID. Well, if you have two VLAN IDs in your packet, essentially, right, when it goes across the native VLAN, maybe the first packet, the first tag will be stripped, but the second tag will remain, and now when your packet ends up on the other side of that trunk, it's got this second VLAN ID, and so you could actually hop VLANs by double tagging a VLAN ID into your packet. Now, another one that we're going to have to work with is STP. STP is enabled by default on switches, and it's necessary when you have multiple switches in a network and you have the possibility of switching loops. And an attacker could manipulate packets and basically control STP and manipulate STP so that they could become the root bridge or the switch that all spanning trees are designed from. So a lot of traffic would then come to the attacker, and the attacker could capture those packets and get valuable information on how to attack the network. So STP is enabled by default, but what we want to do is we want to secure STP by not allowing attacks and STP manipulations. Another thing is CDP. CDP is enabled by default on Cisco switches. It's a layer 2 protocol that gives a lot of information about neighboring Cisco devices. So it can be used for reconnaissance to find out about other switches or routers or Cisco devices on the network. And so typically you want to disable CDP by default. And then last but not least here, we've got switch port security. So these are some protocols that we want to deal with, some VLANs we want to deal with. But down here also, we want to set up some switch port security. So to help defend against broadcast storms, what we could do is we could add some storm control measures on our ports. A LAN broadcast storm is broadcast packets on the LAN that will broadcast out of, let's say, all switch ports, and then could cause a denial of service attack, essentially. Also, we want to make sure that we defend against MAC address spoofing, someone imitating MAC addresses of other devices on the network. And by having port security, what we can do is we could secure each port on the switch so that only one MAC address is allowed. Another thing is a MAC address table overflow attack. If we allow the switch to be bombarded with MAC addresses or bombarded with packets that show different source MAC addresses, then those MAC addresses the switch will try to basically save in its table. And if the table gets too much information, we have an overflow scenario, and then the switch will resort to broadcasting out of all ports, basically turning the switch into a hub and allowing an attacker to see all packets disseminated on the network. So we want to defend against abusing the ports and allowing only, we want to allow only maybe one MAC address per port and not allow new devices onto the switch. And we can do that with switch port security, port security. So its port security is disabled by default on the switch, so we want to enable it. Storm control is disabled by default on the switch, and what we want to do is we want to enable it, configure it, right? And some of these other protocols we want to, they are enabled by default, we want to disable them.